So turns out scientists have found a very thick layer of ozone over Bay of Bengal. Now wait, is ozone layer depleting or is it getting thicker? What is this confusion? Welcome back to the latest update series of Drishti IAS. This is Divya Kawatra, and today we are going to discuss regarding a very different event, a very unique event where we are going to talk about increasing ozone layer. That's right, thickening ozone layer is what we have observed. How is it happening? What is the reason behind this? Let's understand all about that along with some basic concepts regarding ozone layer that you should know for your StarTech prelims. All right, come on, let's do this then. So first of all, let's understand what has happened. Recently, scientists have detected unusually thick layer of ozone. Unusually thick layer of ozone, as you can see this, above the North Bay of Bengal, specifically above the North Bay of Bengal. Now this becomes very concerning, like not exactly concerning, thick ozone layer is good, but then again it is very curious that how is it happening, because it gives new clues about how ozone-rich air is transported and redistributed to the Earth's upper atmosphere. Like whenever we release ozone-rich air, any kind of air containing such elements that are going to go up and actually heal the ozone layer and actually strengthen it and make it thick and then disperse those elements across the atmosphere. How does that work? That is something we will be able to understand through this, right? Exactly. So now this unusual enhancement was found at an altitude of 21 to 23 kilometers in the lower stratosphere. Where did we find it? In the lower stratosphere at 21 to 23 kilometers. How so? We were doing a nationwide observatory through an atmospheric observation campaign, and in that campaign we found out, researchers found out that okay, there is something different here. What is different? Suddenly the thickness of ozone layer has increased. Okay, that was something that they were not ready for. They got very excited about it and then they thought, okay, let's study it, right? So they're observing it and studying about it. But for now, we need to understand what this unusual layer is and how is it persisting over India, and is it there for more than one day or is it just there for some hours? What is going to happen? Okay, let's understand. This is a kind of layer, like not exactly, but how it is encircling the Earth. All right. Let's understand about the key findings that has been done. Scientists detected this thick layer under the phase 1 of NetRAD. What were they doing? The NetRAD-ASMA campaign was going on. That is a coordinated nationwide atmospheric observation effort across India. Under that, they found this out at an altitude of 21 to 23 kilometers above North Bay of Bengal, where they found out that the levels were significantly higher than what is normally observed here. Okay, so it was persistent day and night. It is not like it was only persistent in the day, during the day or during the night. No, an observation tells us that layer persisted for over 24 hours without very significant variation between day and night. Between the day and night, there was no significant variation. It was constant there, consistently existing there without any significant difference. Like slight differences are there because of the air and the movement, but no significant difference to show that any pattern is changing in the night or the day. All right. Secondly, because photochemical creation obviously relies on solar radiation, the day and night consistency indicated sunlight driven chemical reactions are not the primary cause, because generally when it thickens, we go towards sunlight created phenomena. But since it is persistent consistently towards the night as well, we can clearly outfierce that it is not because of the sun. Can we do that now? Yes? Okay, then what caused this? That raises a question, right? If it was not sun driven, then what? So mechanism behind it that researchers that have analyzed, they are saying that this is regarding atmospheric convection, wind shear and vertical air movement. The vertical air movement that settled down there, it kept giving it a layer over layer over layer, right? That might have happened, concluding that anomaly was caused by large-scale atmospheric transport. Sudden atmospheric transport happened because of the movement of the air, and all of it got captured over a single zone, right? That is what they have concluded. So this ozone-rich air from higher stratospheric levels moved downwards and compressed over the region, and at that compression it gathered around and suddenly we saw a very thick layer. All right. Yeah, that is what we have seen. But now how was it tracked? Like how were we able to track whether it is there and for how long it is there? How did we do that? First of all, we had atmospheric radars under the Aryabhat Research Institute of Observational Sciences, that is ARIES. They deployed the indigenously developed 206.5 megahertz stratosphere troposphere radar. Where is this radar located? This is located at Nainital. Okay, that radar consistently observes the atmosphere, and in that consistent observation, if there are any anomalies, it suddenly captures in its data. Then we are able to address that, okay, there is some anomaly, let's look at that. And through that, we were able to see, okay, how this is working. They're working in tandem with radars at Haringhat, Gadanki and Kochi as well, running from Nainital as well. Okay, they are working all together to cover an entire area. Through that, we saw the weather balloons also. The ozone zones, the balloon-borne structures that are observing the instruments that were launched mainly to measure localized vertical profiles of ozone. Like in any area, vertical profiles as to how it keeps changing and how it is growing, right? To gain that observation, this was launched, and this balloon also helped us get the data for this research as well, right? Yeah. Then if we talk about satellites, the data from AURA MLS from NASA and INSAT 3DR from ISRO, both of them have also allowed the researchers to track down this ozone structures, how it is forming, and to gain data regarding that for validating the ground observations, right? To clarify, to cross-check and to analyze it more deeply, they also use the satellites from outside to observe the Earth as to what is changing, right? From Earth, we are sending a radar. Through that radar that is located in Nainital and many other areas, from there the radar was detecting the ozone, and from this ozone on the upper end we had the satellite to observe it from the up as to observe the Earth as well, right? And these two level of opinions have given us the data that okay, this is happening and this is a rare phenomena, right? Exactly. Why is it so significant though? It is significant because as published in Earth and Space Science, that is a journal of American Geology Union, they are, Geophysical Union, they are saying that discovery is going to give us valuable quantitative effective of how stratospheric air dynamics and circulations redistribute. How so? From the Earth, if airs are rising, the air rises with gases. The same gases can either deplete the ozone, right, or heal the ozone, right? They have both the tendencies. How this vertical movement of air along with gases is working on the ozone layer in the stratosphere and how it distributes, right? Because let's say that from this point on, we are sending gases that are healing the ozone layer. But once the healing starts, how will it work? It will get concentrated here. Ozone will get healed at this point. But we need it to disperse over the entire ozone layer. We need the effect to disperse as well, right? If we keep healing this part, at this point we will have a lot of ozone, and at this part we won't have any ozone, right? So we need it to disperse. To understand that, how this is acting at this particular point and how it is transferring the effects to both ends, dispersing it actually, we will be able to understand that very quickly, because now we will watch that happen. We will be able to observe that happen, because whatever is gathered at Bay of Bengal will start spreading out, and the way it spreads out is what will help us understand the mechanism behind it, and maybe will help us heal ozone better as well, right? That's why they're saying it is very important, and will be constantly, very meekly observing it, so that we find out the reason behind this mechanism, the system behind this mechanism, and we are able to replicate it over different areas, right? That's why this holds great deal of importance, and obviously it will help us understand atmospheric transport mechanism as well, right? Exactly. Now that brings us to ozone layer, understanding a little bit of dynamics regarding the physical geography that you have as a static part of your subject, right? To understand troposphere versus stratosphere ozone, this is very important. Generally, all we study is that, okay, there is an ozone layer, that protects us from the UV rays, which is very good for the environment. It is going depleting. We have to save it. There is ozone hole that we need to refill, all that. But that is not only where ozone occurs. Ozone occurs in stratosphere as well as troposphere. It is not just stratosphere, it is also troposphere. But then why don't we talk about troposphere? Why do we only talk about stratosphere and how important is it? Right? Understand. First of all, there is good ozone and bad ozone. The stratospheric ozone is good. The tropospheric ozone is bad for us. How so? The stratospheric ozone, that is 15 to 35 kilometers high, protects us from UVB and UVC radiations. The bad ozone, that is on the tropospheric or ground level, is harmful. Why? Because it is a secondary pollutant. Not a good gas, not a layer, but a secondary pollutant that is formed by photochemical reactions between nitrogen oxide and volatile organic compounds. Because of their reaction, it is formed and it is not healthy. It only heats up our environment and it only traps harmful gases in the structure, right? So ozone layer is present in the troposphere also. We try to get rid of that and we try to save the stratosphere one. Is that clear? Yes? Please understand that for your prelims. And then the dynamical transport and photochemical process, how does it work according to our current understanding? We are hoping to learn more about it through this experiment. But according to the current understanding, we see ozone concentration is not purely driven by localized chemistry or the photochemistry that comes from sun. And the recent experiment obviously proves that, because it is happening in night also. For photochemistry to happen, it should have happened in the day in the presence of sunlight, but that is not happening, right? So clearly it is not dependent upon the photochemistry alone, right? Atmospheric circulation, specifically tropopause folds or stratosphere-troposphere exchange and the Brewer-Dobson circulation that is there, they transport ozone horizontally as well as vertically. It is not just horizontal distribution or not just vertical, it is going in both the directions like this, right? This movement is also there and this movement is also there, and through that we understand how it exactly gets transported. Clear? That is the important phenomena that is happening here. Just look at this ozone layer, UVA, B and C, and this is coming here. This is the tropospheric level where airplanes are there, and then we come to stratospheric ozone layer, right? Surface level of ozone, this is the smoke, then comes in the troposphere, that is harmful for us, and then comes in the stratosphere, right? That is the structure of ozone working here, right? We have multiple institutions working towards ozone layer already. Like, I'll just give you the example, ARIES we just talked about, Aryabhatta Research Institute, working on the stratosphere in Nainital. Then we have NetRAD-ASMA campaign that is already working. Through this campaign, we were able to find out the layer on Bay of Bengal, right? Then we have space-based Earth observations also like INSAT 3DR and AURA-MLS. These two also we've already discussed. All of them are working towards observation for ozone layers. Clear? Exactly. Now, environmental global conventions are also there that are working towards ozone layer. For example, we have Vienna Convention 1985, that is a framework convention for protection of the ozone layer. Montreal Protocol 1987, legally binding treaty. Please understand that this is not a framework but a legally binding treaty targeting phase out of ozone depleting substances. Whatever is depleting our ozone, let's get rid of those substances like CFCs, HCFCs, halones, all that. Then we have the Kigali Agreement of 2016, amendment to the Montreal Protocol. This was an amendment to the Montreal Protocol to phase down HFCs also, not just CFCs, HFCs, hydrochlorofluorocarbon and chlorofluorocarbon, right? Yeah. So here they don't deplete ozone but are potent greenhouse gases. That's why we want to get rid of these as well. And these are the conventions here. Clear? All right. I hope this is clear. I hope this is clear. Recently, we've had a meeting regarding ozone protection. Tell me about that meeting in the comment section. And now, before we solve our question, let me remind you that we have our freedom sale going on of up to 50% off across all these verticals like UPSC, CUET, etc. Especially on the ISGS Foundation, where we have flat 50% off. This is the slash down price. Please look at that. Please take a benefit of it timely because the sale is only live from 11th to 16th August. That also includes mains and optional courses. You can benefit out of this from the Drishti IAS learning app or the Drishti IAS website. And if you face any problem, just give us a call on 87501 87501. Don't forget the dates of the sale, 11th to 16th August. All right. Okay, so on that note, we have this question. Try to solve this and give us your answer in the comment section. Done? All right, on that note, if you want to join us for more such discussions on current affairs, we meet every day from Monday to Saturday, 8:30 a.m. live to discuss the Hindu newspaper, PIB news analysis, as well as questions from the previous session. You can join the class at the Drishti IAS English channel. Join the channel to attend the class live every day, Monday to Saturday, 8:30 a.m. live. All right. That was our session for the day. Thank you so much for joining. We'll see you in the next video. Till then, take care. Thank you. Bye-bye.
For more informative content, like, share and subscribe. And do not forget to press the bell icon to get the notifications.